Okay, this is the last lesson of this unit. And this is all about making lists. And lists can actually be really complicated if you're not paying attention. So we're going to do this whole thing together, okay? Whatever I write, I want you to write. A lot of the language that they use and a lot of the way that they word things here is meant to confuse you and will help you make careless mistakes if you're not really focused on it. So let's start with this first one. It says, Arthur is tiling a bathroom wall. He has 520 wall tiles. He wants to arrange them in patterns of hundreds and tens. Using only hundreds and tens blocks, how many ways can he make 520? So here's how we do this. Using only hundreds and tens blocks. So I'm going to make a list having hundreds and tens. And it's really not a list, it's more of a table. And in this list, each section has to equal 520. How many hundreds do I need to make 520? I need 5 hundreds. How many tens do I need? 2. What would be another way I could do it though? What if I had only 4 hundreds? How many tens would I need?
3.
No.
Oh, no. Sorry.
12. Because 12 tens is 120, and 120 plus 400 is 520. Now let me count down. So what I like to do is on my top number, I like to just sort of count it down and then make my bottom number reflect it. So now I go down to 300s. How many tens would I need? 22, yes. Go down to 200s. How many tens would I need? 32. Going down to 100. 42. Now, I'm not going to go down to 0 because it said using hundreds and tens blocks. He's tiling them. I guess, though, I would just put it in for good measure just to show all the combinations, 0 and 52 tens, so that there are 1, 2, 3, 4, 5, 6 ways. Because it said how many ways can he make 520? There are 6 ways to make 520 using hundreds and tens.
Miss Hall, it said all the answers.
Let's look at number 1. Shh. Let's look at number 1. It cost Celia 50 cents admission to enter the aquarium. How many different ways can Celia pay the admission using only quarters, dimes, and nickels? All right, that means I'm setting it up. Quarters, dimes, nickels. That's my table. And no matter what, each row or each column needs to add up to 50. So I'm going to start with my quarters. How many quarters do I need to make 50 cents? So I would need 2 quarters and no dimes and no nickels. That makes 50. That's all I can do for 2. So now, if I had 1 quarter, how many dimes could I have? I could have 2 dimes, and then how many nickels would I have? 1. That makes 50. What's another way if I had 1 quarter and maybe instead of 2 dimes, 1 dime, how many nickels would I need? 3. Okay, what if I had 1 quarter and no dimes? Can I do that? How many nickels would I need? 5, right. Because 5 times 5 is 25. And then this is 25, and that makes 50. All right, now I'm done with my quarters. I can't do those anymore. So how many dimes and nickels could I have to make 50? I could do 5 dimes and no nickels. So now let me count down that. 4 dimes and how many nickels? 2. 3 dimes and how many nickels?
4.
Yeah. 2 dimes and how many nickels?
6,
1 dime and how many nickels?
8,
We're starting to notice a pattern happening here. And 0 dimes and how many nickels?
10.
10. How many ways? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways. Okay, so this takes some work, and honestly, you have to be organized with this. The reason I start at the quarters and I do everything I can with the quarters and I count down. When I run out of quarters, I start at the dimes and do everything I can with the dimes and count down. If you just try and do it out of order, that's where your mistakes happen, because you forget something. You could easily leave out one of these by accident. So that's why I always want to count down. The bottom one is just along for the ride. I always start at the top, count down until I can't do anything else. And then I go to the next one and count down until I can't do anything else. Okay? So now let's look at number 4. Using only hundreds blocks and tens blocks lists the way to show 340. Okay, this is very similar to what we just did. So a hundreds block and a tens block. And now I'm showing 340. How many hundreds do I need?
300.
3 hundreds. And how many tens would I need? 4 tens. What if I were to take it down to 2 hundreds? How many tens would I need?
8, right?
No. 14, because 14 tens is 140, and 140 plus 200 is 340. What if I were to take it down to 100? How many tens would I need? 24, because that's 240 plus 100 is 340. And finally, if I had no hundreds, 34. So how many ways? 1, 2, 3, 4 ways. Okay, number 5. Simon asked Margaret to guess a number. He gave these hints. The number has 3 digits, okay? 1, 2, 3. I set myself up. The digit in the 100s place is less than 2. Well, what's that got to be then? 1. Can't be 0 or else it's not 100. The digit in the tens place is greater than 8. So what's that number going to be?
9.
The number is even. So that means that this number could be either a 0, a 2, a 4, a 6, or an 8.
Wait, and that's it?
And that's it. It'd be 190, 192, 194, 196, or 198, because it asks, what are the possible numbers? Well, those are my possible numbers.
So if you just put an 8 in, then it would be 1.
That would be one of the possible numbers. It's asking for all the possible numbers, so I need to put all my even numbers in.
So would it be 190?
So my answer is 190, 192, 194, 196, and 198. Those are the possible numbers that it could be with those clues that were given. Let's look at number 6. Make a list showing the ways you can make $1 using only quarters, dimes, and nickels, using no more than 1 nickel and no more than 9 dimes. Okay, so I have quarters, dimes, and nickels again. And I need to make $1 or 100. It doesn't matter how many quarters I can use, but I'm limited. I can only use 0 nickels or 1 nickel. And I could only use 9 dimes or less. So I can't say 10 dimes. So first off, how do I make $1 with quarters? 4. 4 quarters is $1. And then no dimes and no nickels. Okay? What about counting down now? 3 quarters, that's 75. What do I need to do to make the dimes and nickels work? How many dimes? 1, so that makes it 85. So 2 would make it 95, and then 1 nickel makes it $1.
You can only have 1 or 0.
Okay, counting down my quarters. 2 quarters, how many dimes? 5, because that's 50 and that's 50, and 0 nickels. Counting down, what about 1/4? That's 25. How many nickels, or how many dimes? So 20, this is 1, that's 25.
7.
So if I had 7,
Yes. And a nickel. And then 1 nickel.
so 7 plus 25 is 95, and then 1 nickel, that makes $1. Can I do it with 0 quarters?
Yes.
Let's try it. 0 quarters, how many dimes? 9 dimes. How many nickels?
Do it.
Can't do it. I'm only allowed to have no more than 1 nickel. So that won't work.
Is that it?
So 1, 2, 3, 4 ways.
I have a question though. Couldn't you do 3/4?
Cannot have more than 1 nickel. Remember, you gotta remember those rules. And that's another place where we make those mistakes. If we're not looking carefully at what limitations we've been given, we're gonna really mess up. All right, let's look at number 7. This one is a little bit tricky, but once you find out that trick, it actually becomes really simple. For number 7, it says Lou's sandwiches are made with either white or wheat bread and have only one type of cheese, Swiss, cheddar, American, or mozzarella. How many different kinds of sandwiches can Lou make? So what I do when I set it up is like, okay, so I'll start with the bread. I can have white or wheat. Those are my 2 options. I could have a white bread and Swiss. I could have white with cheddar. I could have white with American. I could have white with mozzarella. Or I could have wheat with Swiss, wheat with cheddar, wheat with American, wheat with mozzarella. It doesn't matter how many different types of bread I have. Each type of bread would have 4 possible sandwiches from it. So how many sandwiches could I make in all with this? 8. What if I were to throw in some rye bread? How many sandwiches could I have then? 12. What if I were to throw in some challah bread? 16. So I know that one sandwich can have 4. That means any other kind. If I had 40 different types of bread, how many different types of sandwiches could I make? 160, because 4 times 4 is 16, right? So I do just anything times 4. If I have 10 different types of bread, how many sandwiches can I make? 40, because each sandwich could have 4 different possibilities. So when you have something that's like this, that says, how many different combinations can I make with 3 of this and 5 of that? Well, you just make 1 and see how many goes with it. And then that's it. You've got it. Number 8, a magazine has a total of 24 articles and ads. There are 9 ads. How many articles are there? What is this asking? What's this asking me to do? No. Look at the picture. I have 24 on top. I have a 9 on the bottom, and then I have a question mark.
9 times blank equals 20.
This is not multiplication. It is a magazine, has a total of 24 articles and ads. There are 9 ads. How many articles are there? Guys, this is subtraction. This is division. Division would show me equal boxes that are empty, that need to be filled. How many go into each box? That's division. This is showing one part and another part. And it's uneven too. Whenever you see it uneven, you know it's not multiplication or division, because that's always equal. So what's 24 minus 9? 15. Okay, let's look at number 9. Janie is making a bracelet. She has 1 red bead, 1 blue bead, and 1 white bead. How many possible ways can Janie arrange the beads? I'm going to show you the first way that I want you to do it, and then I'm going to show you the shortcut once you understand it. So, I have a red bead, I have a blue bead, I have a white bead. It is asking me how many different ways I can order it. So what I do is I take the first one and then I switch the other two. So I could do red, blue, white, or I could do red, white, blue. Are there any other ways that I could put that in order?
Yes.
No, there are no other ways. Not with red first.
Oh.
Not with red first. So there's no other ways that I could start with red. So I have to go into blue. So I could do blue, red, white, or I could do blue, white, red. I can't do anything else with blue. I can do white, red, blue. I could do white, blue, red. Are there any other ways that I could do it?
No.
No. And have I done, the other way I can check myself is, have I done each one to start with? Red, blue, white, red, blue, white. So how many did I make? 1, 2, 3, 4, 5, 6. It was 6 in all.
I have a question.
Hold it for a moment. So this is the long way that you're supposed to do it. This is the way you're supposed to understand how we can switch it up and show all the different combinations. But here is the shortcut. How many beads do I have?
3.
3 beads. How many combinations could I make with each bead?
2.
2.
Times 2.
So if I know I have 3 beads, all I have to do is make that first combination before I have to go into the next set. Well, this literally just shows I've got 3 beads and each one has 2 combinations. Equals 6. Now let's test it. Let's look at 11. It says, Alan has a cat, a goldfish, and a dog. He feeds them in a different order each day. How many different ways can he feed his pets? All right, let's try the shortcut way. First, I'm going to write down cat, goldfish, dog. How many do I have? 1, 2, 3. What's the another combination I can make with a cat first? Cat, dog, goldfish. Are there any other ways that I can make it?
No.
No. So I would have to move on to the next one, right? So there are 2 combinations for each one. There are 3 in all, and each one has 2 combinations, meaning that there will be a total of 6. So let's take this a step further even. What if I have a cat, a dog, a goldfish, and a mouse? This makes it considerably more challenging just by adding one more letter. Because now it could be cat, dog, goldfish, mouse. It could be cat, dog, mouse, goldfish. It could be cat, goldfish, mouse, dog. Or cat, goldfish, dog, mouse. Or it could be cat, mouse, dog, goldfish. Or cat, mouse, goldfish, dog. Am I missing anything? C, D, C, G, C, M, C, D, G, M. So that was just for that one. So I have 1, 2, 3, 4. And how many for that one? 1, 2, 3, 4, 5, 6. Just by adding one more letter, it got so much more complicated. But if that's what it was for one letter, it's probably going to be the same for the next letter. If I were to then start with D, C, G, M, D, C, M, G. If I were to keep going, it would be the same. So this I could solve by just going 4 times 6, which is 24. So this makes something that looks kind of crazy go, oh, okay, that's a bit more doable. But you still have to put in that work for that first bit. All right, let's look at number 12. Heather is writing a 3-digit number. She uses the digits 1, 5, and 9. What are the possible numbers she can write? This is the same thing, except there are no shortcuts on this one. It wants all the numbers. You got to give him all the numbers. So 1, 5, 9. 1, 9, 5. 5, 1, 9, or 5. 9, 1, 5, or 9. There we go. Are there any other ways that I can do it? No. And I know I should have 6. 1, 2, 3, 4, 5, 6. Because I already know that when I have 3, that means 6. But I had to show all the numbers because it asked for that. So if I just write the number 6, I'll be like, no, 6 is not a number that you would make. All right, we're almost done here. Number 13. At the driving range, James wants to buy 200 golf balls. The golf balls are sold in buckets of 100, 50, and 10. How many different ways can James buy 200 golf balls? All right, 100, 50, and 10. And I'm trying to get to 200. How many hundreds do I need to get to 200? 2. 2, 0, 0. Okay? What if I just had 100? How many 50s would I need? 2. And then 0. What if I still just had 100, but this time I only had 150? How many 10s would I need? 5. What if I still had 100, but I had no 50s this time? How many 10s would I need? 10. Okay, I think I'm out of my options for 1, so now I'm going to go to 0 hundreds. If I had 0 hundreds, how many 50s would I need? 4. If I had, what if I just had 3 50s? How many 10s would I need? 5. If I had only 2 50s, how many 10s would I need? A lot's not an answer. 10. If I had 150, how many 10s would I need? 15. And if I had 0 50s, how many 10s would I need? 20. So again, the only way you would make mistakes here is by not going in order. I start at my top, 2, 1, 1, 1, and then all zeros. Once I hit to the 0, I started at the highest I could go for the 50. 4, 3, 2, 1, 0. Okay, so counting down will really help you. All right, there's one more thing I want to show you. It's actually not in this book, but there's going to be a question on your Daily Common Core that I want you to see. This is if I have a certain amount of people that I want to put into partners. So let's say I have 7 brothers. And the boys are Jordan, Brian, Mark, Isaac. I'm going to try to go for different letters. Kevin and Adam. 1, 2, 3, 4, 5, 6. And Elon. So, let's say these brothers need to become partners. How many different ways can they be partners? So here's what I do. I go J and B, J and M, J and I, J and K, J and A, J and E. So they've all, these are one way that we could be partners. But this is just J has been with everybody. So now I'm going to go, I've done J, now I go to B. B has already been with J. I also go in order of how it's written. You never go at what's in front of it, you just go with what's after it. So B has been with J, so I start at BM, BI, BK, BA, BE. Okay? Notice how it is one less. Now I've done my B, I'm moving on to my M. M has already been with B, M has already been with J. So M will start with I. MI, MK, MA, ME. Okay, and notice again how it is one less. Now I go on to I. I has been with M, I has been with B, I has been with J. I notice here, if these have already been crossed off, I has already been with them, so I only go forward. So IK, IA, IE. Without making the next one, can I guess how many would be in it?
1, 2.
2. And then the last one would be 1.
Wait.
So this was 3, this was 4, this was 5, and this was 6. So once you start to notice that pattern, really, you don't have to finish it. If I were to finish it, my next one would be K, and K would be with A, and K would be with E. And then the last one would be A and E together.
Sad little.
Because they've just been with everybody else. But you can see how it sort of stacks itself up. Now I'd have to add it all up afterwards. So 6 plus 5 is 11, plus 4 is 15, plus 3 is 18, plus 2 is 20, 21. So there are 21 ways that they could be in partners. But again, if I figured out the trick, I don't have to go this far. I can just start with my 1 and go, okay, well, I know that this rule, but I gotta remember that this is the rule. I know that this rule means I'm doing 1 less each time. Okay? This is a whole different kind of math. We're not doing a lot of numbers. We're having to do a lot of organization and keeping ourselves on track. Okay? Sound good? I know our brains are probably a little scrambled right now.
Yeah.
Sorry.